I'm trying to start. There we go. There. Okay. So yeah, we can go through it. At least one side. Oh, I wrote down the first few. Okay. So of the ones I have, I guess we can just review those ones. So like the first one, what did I say? That was a one sample z-test. Did you get that one?
Was this the Journal of
one.
Small Business Management?
Yeah.
Journal I just put like letters in, so I'll have to go back.
Oh, A.
I think I actually got H on that one.
Oh, H. Which one's that one?
Chi-squared or chi-squared.
Oh, okay, yeah. I think the biggest thing is knowing if it's quantitative or categorical.
Oh, yeah,
true. Because if it's like categorical, then it's the chi-squared and the.
So if they're comparing education level, doesn't it for chi it has to be like 3 or more? 2 or more? 3 or more? I don't know.
Yes, at least more than 2. I think it's
yeah,
like 3. Let's see. Oh, no, you're right, because it also uses independent and not independent, which is the hypothesis for that. Yes, you are right. Because I was thinking like that you would have like the numbers of people in those things. But then it's only, okay, I don't know what I was thinking. Yeah, you're right.
No, I got you.
Because it is more than one. Okay. Then number 3. This one. Now I'm like double thinking on my answers.
No,
I think I got a once. No, it was either one sample t-test or the one proportion test of one proportion.
Test of 2 proportions. I feel like I'm real bad at these parts. Like, I don't even trust myself on them, so I'll read again.
I think what I'm gonna do is on my page, I'm just gonna have like a blacked out part, which is like a really cool edit like chart.
So we're testing the 2 groups, right?
Let's see. Two groups, yes. Yes, it would be 2 groups.
So it'd be proportional.
But then are we looking for numbers or like just people in a, let's see.
I feel like it would be a proportion because it's how many out of each group.
Oh, true. Like a big group?
Yeah.
Like out of the amount of people? Yep. So like 2 proportions?
That's what I think so.
Okay. Yep, that makes more sense. I think I was just thinking about these like not in the right way when I was doing the prep.
It was so yikes.
Okay. Number 4. This one I said it was an independent sample t-test, but we'll see.
So I'm kind of confused if we're even testing 2. You know what I mean?
What do you mean? Oh.
If we're even testing 2 groups, because it's just like out of the 248, we're testing 152. Or there are 152.
So I took a sample, and then like a ratio of them were considered heavy players, and then another ratio were considered male. Oh, so we're just testing. Wait.
Is it just the one proportion?
Yeah, because we're like comparing the proportion of the sample to the proportion of the population with a known mean already. So technically it's not like 2 samples. So I think it's just 1 sample. Yeah, 1 sample. But it says proportion.
Yeah.
So like a test of 1 proportion?
I think so.
Okay. Yeah, this is going to be the biggest thing I'm going to go over.
Me too. I still need to practice this before I take the test.
I know. Oh my goodness. I'll make a real big pedigree. Okay, question 5. Oh, my numbers are messed up because this one is numbers.
Oh, yeah. Because we're on 4, I think.
Yeah. Oh. Put independent sample as well? This one?
I put paired. Because they do it once and then they do it twice. Like again.
Yeah. Yeah, and I was like, oh, but then I was like, would it have an effect on the next one? Yeah, you're true. Or you're right. Because that is true. Because I was like, no, it wouldn't affect the results. But it is the same person.
Exactly. The next one is one I had a question on. I'm not 100% on it.
Mm-hmm. This one, I said ANOVA for this one. Let's see. But it might also be, I don't think. To make sure. But they don't give like anything, so it might be. Oh, wait.
I'm trying to decide if it's paired or not.
Apparently I'm on the wrong number because question 6 doesn't even have ANOVA.
Oh no.
Or did I say? Oh, all my numbers are messed up because I started with 1, but this started with 2. So
Yeah.
Anyway.
Okay.
Well, this one we just have multiple, but about 6 properties. So it couldn't be the ZT paired independent. But it doesn't, because only like multiple like sample ones are like ANOVA and the chi squared.
That's true.
Unless they're chunking it differently. That's a hard one.
Because I can't tell if it's asking if they're the same, like all together they're the same, or if it's like on each property.
Oh, it says 2 appraisers. So they brought in 2 people.
Yeah.
Oh, and then it's important for them to appraise them like the same. So each person would appraise each house like the same. And oh, so they looked at 2 oh, wait, okay. So like each person out of the 2 went and appraised a home. And then what the people were doing was they were looking at both samples from one appraiser and another appraiser and comparing them. Oh, so then we'd be looking for the difference, right?
Yeah, so I'm not sure if it's paired or independent.
Would you say it's paired because it's the same houses that have been appraised twice?
Yeah, that's what I had first, but I'm like, I'm not 100% sure.
And Well, because the reason I think it would be paired is because if they would have to compare one house to like that's like the one appraisal
The
of one
same.
house to the same house. Like it wasn't just
makes
like random houses compared to each other. It's like this house is
Okay,
compared
means
to
that- yeah.
itself.
Okay.
Like anyway, but I could totally be wrong. But that's just
Well, if we're wrong, now we know what's right.
yeah.
Yeah.
Okay, 7. Oh, and then this one. Because this is also testing the difference.
Yeah, so I put independent on this one.
Mm-hmm. 7. Because they went to one place and did the study, and then they also did a second one, but they were like completely separate. Yeah.
Yeah, different.
Yeah, I agree with that.
Okay.
Let's see. Two proportions for this one. I put down a test of 2 proportions for this one, but now I'm looking at it and I'm like,
I'm not sure that it's proportion
and
because are proportions quantitative or categorical?
they're categorical. But this one, I'm looking at it and it says the true assertion, or like true, what is it? Like amount. The true,
Yeah.
true mean feeling. So that would be the T sample or Z sample. Or,
I feel like it's a one sample T.
yeah, it's definitely one sample. And we do not know sigma. Doesn't seem. So yeah. T. Oh, this is where I start getting into the.
This is where you start what?
Wait, what? Are my numbers actually matched up? Because 9 is where I started going into A, B, C, D. Oh.
Oh.
Yeah, what did I put? D for this one? Oh, but they're all different.
Uh-huh. That's okay.
No. Oh, so significance level of a hypothesis test. I put on this one letter D, but I don't know. Like, I think it's different. But I think it's the first one, A.
Significance level?
Oh. No, C. Sorry.
C, yeah.
Yeah, because the other one. C.
The other one will be?
Yeah, then the other one, I think. Yes, p-value. That one's C, right?
Yeah. Yeah.
Okay. Let's get this flipped. Yeah.
For 11, I always just look at the most complicated answer, and it's most likely that one.
It's the one 95% of all 95% confidence intervals. That one. Yep. That's the one that I don't really like. I understand it, but I don't really understand it when I read it. So I'm like, oh, it's that one.
Why are there 70%? Yeah.
And then 12. Oh. Wait, are you sure this is this one? Oh my God. Well, this is not the same. What did I say for 11? I put B, which was 17. So this one.
Did you get 30? I actually don't know how I got that.
10. Ugh. I put 70 B on the thing, but I forgot how I found it.
I know, now I'm like trying to think.
Hold on. Because this is where we go back like many chapters ago, and it's like, oh, I don't.
Yeah.
Because to find the mean distribution. Because the hold on. Because the distribution is different than sigma, yes?
Yeah. So I just have the mean equals P, but I don't know if the distribution is different than that.
Yeah, why P? What? Because the P is like proportion. And which it would be 0.30, or I mean 30 then. 30.
Yeah.
We can try 30. Because if it is. My goodness, wait.
Now I'm not sure about my answer.
Hold on. I'm just thinking about this way too much. It says, what is the mean of the sample proportion? Which is the mean that they gave us, isn't it? Like what you said?
Yeah.
I was looking at distribution.
I know, and then 3 off. Me too.
Asking for the mean, not the distribution. Oh, okay, just kidding.
Would it just be 0.3? Is that what you said?
Yeah, 0.3.
I think so. That's what I want to say. No, I don't know.
I was like, oh. Yeah, 0.3. Sorry. Now that I actually know what it's looking for. It's looking for the mean, not.
Okay.
Oh, the standard deviation, which is sigma. And this one, what did I say for this one? Question 30. Oh, wait.
Do you have a class after this right now?
I do at 12:45. I'm like, oh, dang. But that's okay. We can get through as many as possible. And then I don't know if you want to finish it on your own or we can like have another video later or.
I'm trying to remember what the end's like. I feel like the end wasn't bad. I was just plugging it into Excel a lot. So.
Yeah, and that's not bad. I think it's more like the concepts. Yeah.
Okay. Standard deviation, I got 0.046.
Oh, yeah, I did too.
Okay, good.
Okay, this is kind of where I stopped. So this one I'm like thinking, okay, how?
Yeah.
Probably. Because that's like p-value.
Yeah. I have an answer, but I'm trying to remember how I got it.
Yeah, I'm like, it's just the equation. I'm like, okay, like, how do you go about finding this one?
Oh, wait.
Don't I need a z-score so I can find the probability of
Okay,
the
she
left
talked
side
about
of the.
this is the one. Okay, so she talked about this in the test review. Did you
Mhm.
watch that?
Yeah, I did. Which one was this one?
So she had a problem like, what's the probability of a random sample of 120 adults will be less than 0.3 or whatever?
Uh-huh.
And so
I think.
she just used the equation z equals p hat minus p all over the square root of p minus 1 minus p all over n.
Oh, so that is a newer one.
Yeah, I hadn't ever seen it before. I was like, I don't know how to do that, but then I remembered.
Yeah, I'm like, that's no. Okay, yeah, I haven't seen it before either. Okay, wait, I'll write it down and then figure it out. So you said it was z times p hat minus p.
Z equals p hat minus p.
Wait. Uh-huh.
All over the square root
Mhm.
of p 1 minus p,
Mhm.
and that's over n.
It looks vaguely familiar, but yeah, I have not used it probably this like whole time.
Yeah.
Okay.
And I think you just plug in 0.25 for the p hat and then just go from there.
Oh. But then the p is like the.
0.3, what they
Oh,
gave
true.
us at the beginning.
Oh, yeah, that's true. So it'd be okay. Oops. Okay. And then I got my z-score. But
Oh wait, I don't. What in the world? Did you get an answer to that?
yeah. 0.137.
You did what? Sorry.
So 0.138.
Okay, yeah, so did I. Perfect.
Okay, I know what I'm doing. Hopefully. I feel like this is. Oh, no. Okay.
That's annoying. I don't want to
Oh,
do the
what?
march. It just wasn't on this. I'm like, ugh.
Like, okay. I just need to find the upper bound and lower bound. Or, actually, no. The equation, wait, there is an equation for margin of error for this one. Let me find it. Oh my god. Oh man, this is a really big one.
Is it?
Because this is the P1 and P2 or whatever. It's the inference of two proportions, right?
Oh no.
True proportion. Yeah, so this is the one. This is the one. where it's like z times the square root of p1, 1 minus p1 over n1 plus p2, 1 minus p2, over n2 or whatever. That one. That's this one. Let's see. We have to find the mean for the two.
What are we doing?
Are you finding the proportion of the mean?
Are we doing margin of error right now? What are we doing?
Yeah. So that's how you can find the margin of error. Or that is the margin of error. Okay, hold on. I do.
It's going to take a while.
I know, it's like, ugh.
So is the x like 579 or oh gosh.
X. Oh, like the amount given. Oh, well, this is like just the or we just find the proportion of each one and then put that in as the p hat 2 into the really long equation. Let's see. And it's 95.
95%, yeah.
Yep. Okay.
Okay. I think it's December 9th. Tell me, December 9th. Yes, we're going to do
Oh my goodness. Hold on.
I don't.
Ugh, my goodness.
Okay, just to make
This is
sure I'm
like the
doing this
longest
right.
equation. Uh-huh.
So we're doing 15 out of 579. And then
Yes.
61 out of 1563.
Yes. Yes.
Okay.
You're good.
Yeah. I think the only thing that ever got me was photo system.
Oh my goodness. Okay.
Just because, like, that's the stuff I, yeah. Just forgot all about it. Like, I was so focused on, like, aerobic respiration that, like, I just, like, completely forgot all about, like, my respiration and everything. Whatever, man.
Brother Christensen said he'll probably curve it like 6 points.
6 points. Okay. Well, I mean, I guess I could. Let's see if we're gonna get. That's crazy. Oh, it's up.
Okay. Freaking long. But I finally got the lower bound.
Yeah, I do not have it yet. Sorry.
All right, fine. I still have to do the upper bound and then get the, wait. Oh, no. Okay, what I'm gonna do is
they're just gonna, they are. They're cute little, they are. And I was giving Talea and Alea and Kalea and Julia all mixed up, so I was giving them big names. And I gave them like So Sass, Two Fly, and I was giving them, and then I can remember their names, like, I remember it was Alea or Alea. That's cute. So, they probably like that. And then Maddie. Yeah. It was like all the, I got all really, this, you're Maddie. And Maddie's so good. She's behind, you know, she works so hard. But I don't notice that, you don't notice it, especially in hip hop, it's a technique. But she comes to it. She does, she's been doing good. And then, so, you know, tomorrow night dive, and next,
See.
Not doing this.
Whatever. I'm just gonna find the upper bound and then subtract the two. This is too complicated. Okay.
I'll take care of him next week. Whoa. I need to start there. Yeah.
I feel like there's no way I did that right.
Okay. Here we go.
I think it's down this one.
Well, I didn't know that because I like went down there and I was like,
Okay, so what'd you get for the margin of error?
I was putting in this wrong one. Hold on. I gotta fix this. No, I put in the wrong. Sample thing. All right. I can do this. One, just give me a little bit longer. Oh. Okay. Oops. 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 Oh wait, no, I'm right. Okay, I'll subtract these two. I got 0.886 or 0.887, sorry, with rounding for the margin of error.
Okay. I got not that. I'm almost 100% sure I did wrong.
Okay. Well, dang it. So what I did was it gives you the equation for the confidence intervals.
Mm-hmm.
Instead of that. Anyway, but I'm disregarding it. So like the confidence, the big long ones for the confidence intervals. And then when you get the confidence intervals, all you do is you subtract the higher bound from the lower bound and divide it by two. Oh, I didn't divide by two. Divide by two. And
I
so
got 0.016.
Okay, I got 0.443. Actually.
Oh, no.
Like in half.
Yeah. So when I did it originally, I think I just plugged it into Excel or something, and I got E on the practice thing for the upper and lower bounds. So, like, what do you get for your upper and lower?
The negative 0.4 and the 0.29. Oh, yeah. Okay. I think I definitely didn't do it 100% correctly. Because I got the 0.04 right. Just not the upper bound.
Yeah. So you have your upper was 0.2029?
No, my lower was the 0.04. Negative 0.0 or negative 0.04, but not the.
I'm gonna have to redo that one. I'll have to do it later.
Yeah, that one's just really complicated. But yeah, normally for margin of error, like since we do have the confidence intervals, like you just have to pick which confidence interval it is, and then subtract the higher one from the lower one and divide it by 2. So like 0.29 minus the negative 0.04, and that's 0.33, and then just divide it by 2. And that's 0.165, and that would be like the margin of error for that one.
Okay.
If that makes any sense.
Yeah, it does. Yeah.
Yeah. Okay. But it's just getting the confidence intervals first. Ugh. Anyway, but
you
do
use
have
first?
to.
Did you use like 15 out of 579? What did you use first?
Oh, what did I use for what?
For P1?
Oh, I used the first one, the 61 out of, or no. Yeah, 61 out of 1563. Yeah.
Okay.
And then 15 over 579 was the second one.
Okay, that's how I did it too. Okay.
Okay, good. Oops.
When do you have to head to class?
Probably about now. But we could finish this up a little bit later. Like today, I finished classes at about 4:30. Or oh yeah, because you're not free after 2, are you?
Well, today I am, but
Oh, okay.
I don't know. I'm gonna.
Okay. Well, we could
I
definitely.
guess if you want to do it.
Oh wait. Are there only a few more questions? Oh no, there's a lot more. Dang it! I was like, oh, we can finish. Oh, never mind. Okay, but we could, meet up a bit later and then finish if you wanted to. Or if you feel like you can do it, then totally good. But
Well, I felt pretty good about the rest of them because it was just plugging it into Excel. Honestly.
Yeah, no, that's
So
okay.
if you just finish and then text me if you have any problems. I don't think anymore, but I think I'll be okay. And then take it on your own.
Yeah, which is all good. I trust you, and good luck, because I think it'll be good. Okay, cool. Well then, I will run to class now and see. Have a good Thanksgiving break. Good luck with everything. Yeah, and see you next time.
Yeah.
Bye.